Good morning, everyone. Hello, good afternoon, or good evening, wherever you are. My name is Robert Schmid, Deloitte Digital's Chief IoT Technologist, also known as Mr. IoT. This week on Coffee with Mr. IoT, I'm going to pronounce the T better. I am missing my co-host, Rachel Mohrmann. She's on vacation, enjoying herself in Europe. But I'm talking to Dan Rhodes, a specialist leader in Deloitte Digital, and specifically in the IoT practice. And we're going to talk about IoT and protocols and networks. Hi, Dan. Good to see you. How are you?
Fantastic.
Oh, I like fantastic. It's good. Dan, I invited you because you wrote a blog post and you're writing a white paper actually right now. But before we get into that, tell us a little bit about your background, why you joined us, what are you doing? I mean, you know, one of the reasons we asked to talk to you and we brought you over was because of all your background with devices, but you have way more than that. So just tell us a little bit about yourself and do a little intro, please.
Yeah, sure. So I've been designing products and you know, things that live out in the world in the IoT space for a very long time. Back when I first started, it was sending data over phone lines, which was that was how we got on the internet. But yeah, you know, I've designed all kinds of stuff in a bunch of different industries. You know, stuff in the defense world that has to go, you know, live out in the ocean, to, you know, medical devices that people can use for alcoholism treatment. So big range of stuff. So I joined Deloitte. I ran a product development consulting company for about 8 years, and I was such a control freak that I didn't want to hire anybody, so the company never grew. But and that sort of limited the size of projects I could go tackle. So I joined Deloitte to go do some bigger and better things. So,
well, welcome. It's good to have you. So I have to ask you, defense things that live out in the ocean. Can you tell us, or do you have to shoot me if you do tell me?
Yeah. So this was really cool. So I don't know if you remember back in I think it was the late '90s, the USS Cole bombing that happened. I forget where it was, but basically, some guys took a little Zodiac right up to the side of the ship with a bomb on it and blew a hole in the side of a Navy destroyer. And so at that time I was working for a defense company called SAIC, and we came up with it was a sonar fence that you could stow on board. When you pulled into a port, you could deploy it in about 10 minutes around the perimeter of the ship. And we used 3 different frequencies of sonar to basically track things underwater, and we could pick them up when they were about 100 to 200 yards away from the ship, and we would predict their point of intercept. And it was pretty cool. It knew the difference between a diver and a dolphin, and was pretty cool stuff. And then it was basically a string of buoys, and if someone tried to drive a boat through the buoys, there was a console on the ship where it would tell you where someone was trying to break through, and it was a cool project. So that's the fun part of the defense world.
USS Cole. I just Googled it. October 12, 2000. That was, and
yeah, there we go.
Somewhere in the Mideast. But in any case, I'm curious now. So this is like 16 years ago now, right? What has changed in 16 years, and how would this look different today in the world of IoT? What do you think?
You know, it's funny. Some things have changed, but some things have not. So, you know, even before that, you know, going back to like 99, 98, you know, people were still doing what's now become kind of the standard IoT architecture, where you have a device that lives out in the world. It sends its data back to a server somewhere over the internet. Now it's the cloud, but really it's a server that lives somewhere in a rack, you know, at some facility. And then that data is processed and put up onto a web page for people to access, right? For their business or for whatever their application is. So that model really hasn't changed at all, but how the sensing is done and how the data moves and how the data is processed has changed. I mentioned, back in 2000, we were sending data over phone lines, right? And we were using, this was before Zigbee was a standard. And so we took apart some cordless phones and found out what kind of radio chip they were using, and we made a radio out of it and wrote our own mesh network. And you just sort of had to do all those nuts and bolts things yourself. But now you can, just license a Zigbee stack and, use a processor that's got an onboard radio peripheral. It's great. Things are a lot easier now. So
it's funny that you say things is a lot easier, right? Because one of the things we see when we go and start talking to clients is it's really so much easier to do stuff. And so as a result, there's a lot of pilots and prototypes going on that are built with pieces you can buy at Fry's if you like, or online at Arrow or whatever you want to go, right? And so it's very easy. Let me come back to, but the problem then is, how does that scale, right? How can you make that into something that scales? So that's when we talk about pilots and prototypes, we spend a lot of time on reference architecture.
Yeah, and also along those lines, I mean, because it is so easy, a lot of times what we see is, an engineer, maybe they've used a Bluetooth module, right, and had some success with that, and now they say, oh, well, I'll just add a cellular modem to the product. It's just another wireless module, right? Well, no, there's a lot more baggage that comes with it. So it's easier to get yourself in trouble because there are a lot more options out there for implementing technology. So
it's fun, right? Today we're having a coffee with Mr. IoT that, by the way, a show we do every week at 9 a.m. Pacific, noon Eastern. And today my guest is Dan Rhodes. But the last few weeks we've had a bit of we really talked about business, and we talked about the business value, and we talked business applications. I'm excited today we're going to geek out some, and you started already geeking out with me by mentioning Zigbee and mesh networks. What's Zigbee for people that haven't used it? What is it?
Yeah, so Zigbee is a mesh networking protocol. And so what that means is when you're moving data around in a system, it used to be that a device would gather data, it would send it to a gateway, and that gateway sent it to the cloud. Or if the device had internet connectivity, it would just send it directly to the cloud. So for very small, low-power devices, usually they don't have an internet connection if they're wireless, because internet connectivity requires a higher power type of technology. And if a product is far away from that gateway, you still want to be able to use a low power radio to move that data. So what mesh networking does is it lets all of the devices in the system talk to one another and figure out the most optimal way to relay data from one device so it gets to the gateway in a mesh fashion. So Zigbee is probably the best known mesh protocol. It's been around since the early 2000s. They were touting it. Philips was touting it was going to be in every single light bulb. That hasn't really happened yet because it does come with some baggage. But it's a very powerful thing if it's implemented right.
Why don't we all have Zigbee in our phones, and then stuff just hops across from phone to phone until it eventually reaches a better spot rather than having cell towers?
Well, I know that I'm not the only one that's cursed my Bluetooth connectivity from time to time, or my Wi-Fi connectivity in my house. Amplify that by about 10x, and that's what it's like working with Zigbee. Because it's a mesh network, they also try to build in self-healing, where if one node goes down, another node can pick up the slack, right? And when it's working, it's great, but when it's not working, it is a royal pain. And configuring the system and installing the system takes some real forethought, and consumers are not ready for that.
So it's a little bit of the reliability of the connectivity isn't as good, and if you send data, that's okay if it has to be resent twice or 3 times. If it's a conversation like us and it has to send my words 3 times and you have to wait, that's not as usable, so that's one of the problems.
Yeah.
So Dan, in your article, let me go back to that. You talk about, and you talked about this before, how Bluetooth versus cellular, and then you talk about satellite in there. Tell us a little bit about what the choices are and how we go and how you go about picking the right choice for the right sensor.
Yeah, so when you're talking about mobile devices that are moving around, within some region, it could be all over the world. It could be within a
You mean
city.
phones right now, or you mean sensors?
What's that?
You mean phones when you say mobile devices, or you mean sensors?
Could be either one. Basically, anything that has to be connected to the internet, that has to go move around in the world. That's what I mean by a mobile device.
Okay.
So there are really three options, right? There's cellular, just like our phones use, and those networks have been really developed. I mean, they started as a way for people to communicate, right, as a replacement for the landline telephone. So that technology still has that bias. So when you're using it for an IoT device, there are things about the cellular network that you have to take into account. But it's great because generally wherever there are people, there is a cellular network now. So it can be a really good choice.
What's the cost of this? Now you imagine you deploy one of those IoT solutions. You might have thousands of those. Does that mean you're going to have 1,000 phone bills?
Let's see. So usually the way the data plans work is you'll get a bulk data plan that says, okay, for every device you have, it's kind of similar to the family plan, right? So if you sign up for a family plan, you get 4 phones on your plan. As a company with 1,000 IoT devices all on the cellular network, you get a family plan, right? And it has as many devices as you want, but in essence, that's what it is. And you pay per megabyte, and generally you can get plans that are pooled. So if a device doesn't use all of its allotted data in 1 month, another device can use that unused portion, and that can be a really powerful thing when it comes to kind of controlling costs, especially when you're occasionally pushing out firmware updates and using more data than your regular application would.
So I met with a guy once in Newport, and he created a solution. I found this interesting, just to talk about real-life solutions, where he worked with high-risk auto loan guys. Mm-hmm. And one of the side effects of this is that they have a lot of repos. They repossess a lot of cars. Mm-hmm. A lot of people don't want to return their car. So he developed a solution where he put a chip into the car. It was in the electronics somewhere. And what it did is, after a certain amount of warnings and so forth, at one point in time, they couldn't restart the car. And it communicated through cellular mm-hmm. back to the mothership. And so it's one of those IoT solutions, right? There was a chip, it needed cell communication to tell it to not start it anymore. And he told me that he now gets plans, and if I remember this right, they were about 50 cents to $1.50 per month per device. Mm-hmm. Does that sound about right to you?
Yeah, that sounds about right.
Really a nice low number to work with. So $1 or below for a cellular connected IoT device. Is that about right?
Yeah, I mean, when you develop a cellular product, basically you it's not like you just build the product and then go to AT&T and say, okay, here's my product. Now I need a data plan. You really work with the carrier or MVNO that you've chosen for your application, right?
So what?
MVNO, Mobile Virtual Network Operator. So that's a company that works with several carriers to kind of increase your coverage footprint and deal with roaming costs. But generally, you say, okay, here's my product, this is my application, this is how much data I expect to use, and then they'll give you a data plan, and you can negotiate pricing, and as you get more and more devices in the field, the price per megabyte generally goes down. And there are things that add cost, like if you need a VPN connection, rather than a public IP address. You have that option, and that'll drive the price up. But yeah, it's that's how it works.
It's not quite my phone bill, but I'm pretty happy with my $20 a month plus gigabytes. So that's cell. What other choices do I have, and help us understand when I choose what? Give us a little bit of an intro. I know you wrote some really nice bullets about the different considerations, and I know we're not going to get through all of it, but just give us a little bit of a thought around cell and satellite. I'm particularly interested in the Wi-Fi piece because we are all used to having Wi-Fi that's kind of short range within the house, and I know there's Wi-Fi now that goes 3 to 5 miles in open range scenarios, which is fascinating to me.
Yeah. So yeah, satellite. Just quickly, it's a satellite phone. Really, you really are talking to a satellite.
How big are they?
Well, it depends. I mean, the modems are, you can get a modem that's, say, 3 inches by 3 inches. The modem is generally the smallest part. The antennas tend to be a little bit larger because the signals are so weak. But yeah, satellite coverage gives you global coverage. There are two types. There's Iridium and Globalstar. Iridium is truly global. They've got, I think they've got 60 some odd satellites orbiting the Earth all the time, and that actually is a mesh network. So if you talk to a satellite, that data has to go from the satellite to a receiving station on the ground to get put onto the internet. But any one satellite may not be able to see a ground station because there's only a few of them all over the world. So the satellite you're talking to is probably relaying that data to another Iridium satellite, and it'll bounce around until it makes it to the ground. So that's pretty cool. Whereas
cost per month?
What's that?
Cost per month?
Cost per month, it varies quite a bit. Generally, it's a lot more expensive than cellular. I think usually you're going to be in the range of, well, it depends how many devices you have, but $5 per megabyte or per month for let's say your device is going to use 5 or 10 megabytes per month, right? And you have, let's say you've got 10,000 devices out there. Generally, you'll probably be paying in the neighborhood of $5 to $10 per month for that device. So it is quite a bit more expensive.
So 5 to 10x from cell.
Yeah. So Globalstar doesn't give you global coverage. They actually just kind of cover the central band where the population is mostly concentrated. And the drawback to satellite, either type, is the signals are very weak. So if you're say you're in an urban environment with a bunch of buildings, the buildings cast shadows, just like light shadows. Well, RF is, you can kind of think of that as light, right? If you go into a shadow, you won't be able to, you'll get a dropped call, basically. But yeah, so the LP-WAN piece is pretty interesting. So this is low power wide area networks. And really there's this, because IoT is really, it's expanding rapidly, right? And the applications are popping up faster than the connectivity technologies can keep up. So satellite and cellular developed so people could talk on the phone, and we co-opted that to use it for data. The low power wide area networks are really purpose built for IoT. They're super low power, and they allow devices to communicate with a base station over very long ranges. So you can make devices that are very small and that can have batteries that last for years. So it's very cool. And they're maturing as we speak. So it's pretty exciting. It'll be interesting to see what happens in the next few years with those.
Is it true? It seems to me every time I meet with people working in that space, many of them make proprietary changes to the protocol between the sensor and the gateway. Is that true? And why is that?
Let's see. Sorry, I got distracted by the beeping that I'm trying to turn off here.
Some people are having questions. And by the way, just to remind everybody, this is Robert Schmid and Dan Rhodes from Deloitte Digital. We're talking about IoT, today specifically networks, and this is Coffee with Mr. IoT. I guess the questions we get is around use cases of what we're talking about. So maybe tell us a little more about the protocol, and then I'll stop geeking out, and maybe you can give us examples for when would you use cell versus when would you use satellite, and when is the Wi-Fi piece best. So give us a few examples.
Sure. So let's say you want to track pallets as they're moving around in your supply chain, right? You put a pallet on a truck, and you want to track it from the time it leaves the factory to when it arrives at its destination. Generally, if it's in a truck, it's going to be traveling by road, and cellular would be a great choice for that because the chances of having connectivity along that whole route are very high. Whereas if you had to track a container that went on a ship, there's no cell networks out in the ocean, right? There's just a bunch of open space. So a satellite solution would be best there. If you have a device that you have to deploy for a very long time period, and you don't have to move a lot of data, let's say you're sampling air quality in a city, right? You put a sensor up on top of a building, and that city has a low power wide area network available. That would be a great choice because you could just go up, put your sensor up there, and really not touch it for years potentially. So those are three kind of obvious use cases, but really, I think that there's a lot that goes into this decision. And you can kind of separate it into what I call mission requirements and cost requirements. So the mission requirements are really, what is the application functionally? What does it have to do? What's its job, right? And the things that allow it to do that job well do have an effect on the type of communications technology you choose. So if you have to have a device that's, say, the size of a golf ball, and it has to have a battery that lasts for years, well, cellular isn't going to work, and neither is satellite. But on the other hand, if you don't care about size and network reliability and connectivity is your main goal, cellular would be a great choice because those networks were designed to be super reliable. So really, you have to look at the whole application, but you can't ignore the cost side of it, right? So cellular, like we talked about earlier, you have a data plan, and generally that data plan is going to be, for a cellular application, you're going to pay a lot more for data than you would in a low power wide area network application, right? Because those networks are designed to handle lots of data and large data volumes. So the infrastructure is just more expensive. Whereas the low power stuff is designed for small data. But there's also things like R&D costs and certification costs. Cellular, you can pay if you're developing a GSM solution on the cellular network. Expect to pay $60,000 to $80,000 just to get your device certified to run on a network. Whereas satellite is less expensive because you really only have to deal with Iridium or Globalstar. It's just simpler. And the low power technologies, those use what's called the unlicensed band in the FCC spectrum. So those frequencies are specifically set aside to not require lots of certification. So you can design your radio, do some very cheap, like $1,200 FCC testing, and you're done. So those are some of the high points.
So Dan, thank you. This is really interesting. As you can tell, we spend a lot of time thinking about this when we work with clients on either designing a new product or a solution. We go through that. I have to admit, I was very fascinated to know that, learn that now we can have sensors about this big, and they have a battery in it that lasts about a year or two without having to change anything. But obviously, battery changes are a big part. We just got a question here, and it says, do you think connectivity is going to be the major hurdle in helping clients be IoT enabled, or will the right platform provide and solve clients' IoT use cases? So maybe this is a question for you, Dan, and then I just wanted to give you a chance to close out by, I know you do all this high-tech stuff at work, and then you go home and in your spare time, you built something very low-tech out of tubes. I don't want to take it all away from you, but maybe you can tell us about that as you're closing things. So maybe answer the question about connectivity. Is that a major hurdle, or don't you think so? And then just take your personal thing, and I'll close it out after that. Thank you.
Yeah. So so really, I don't think connectivity. Right now, we have enough choices for connectivity that it's not going to really prevent any application from being realized, right? I think that what we'll see is connectivity will get cheaper, and it'll get more standardized, because connectivity isn't just about what RF or radio technology you use to move your data. It's also about the protocols. So the protocols right now are maturing as well. There's things like MQTT that are really doing great things in the IoT space. So I think we'll see a combination of standards being brought into connectivity, and also we'll see, the technology options tailored to IoT. So cellular is a great example. There's a category of LTE that's going to be released in 2017 that's really designed for small, low-power devices. And once that hits, we're going to see things explode. I mean, there's just going to be all kinds of cellular devices out there, and their batteries will be able to last for 2 to 3 years with cellular connectivity. So,
isn't it interesting? I've heard that the opposite actually true too. That the cell providers have invested so much money into networks, and nobody uses 2G anymore, and soon 3G will be dead too for regular use. And so now they're selling off bandwidth on these antiquated protocols very, very cheaply and inexpensively to people like us in IoT.
Yeah, and that's true. And also one of the big advantages of LTE, the reason they're moving away from 2G and 3G is that LTE is very much software defined. So it's not an actual circuit that implements a 2G protocol. It's a processor with an RF subsystem, right? And it's up to the processor to figure out how to use those frequencies. So to implement some new flavor of LTE connectivity, you really just need to upgrade your base stations. So that flexibility is going to be huge.
So what about that thing in your corner there, Dan?
Here, let me take us on a walk. So let's see. So that, I don't know if you can see that. So that's a vacuum tube guitar amp. It uses tubes that haven't been made since the middle of World War II. I found them in my stepdad's attic, who restores antique radios. And it's interesting because in Europe at that time they would tax equipment based on how many tubes it used. And so that particular tube that I used for that amp performs the functions of like 3 or 4 different tubes, and it sounds fantastic. But it's great because instead of designing things with 1.8 volts or 3.3 volts, that uses 600 volts, which is on your toes. So it's fun.
Well, Dan, it was great to have you. Thank you so much. This is the end of Coffee with Mr. IoT. Please join us again next week. My name is Robert Schmid. I am Deloitte Digital's Chief IoT Technologist, also known as Mr. IoT, and we have this video broadcast every week, Friday, 9 a.m. Pacific, noon Eastern. And with that, thank you, Dan. Thank you, everyone, and I'll looking forward to seeing you again next week.
All right, cheers.